Space is vast. We measure it in light years, the distance light travels in a year. But the universe is not just big, it's filled with mysteries that challenge our understanding of reality itself. One of those mysteries, infinity. The ancient Greeks grappled with the concept of infinity. They gave it a symbol, omega, omega. Omega represents the end, the ultimate. But what happens when the end is boundless? This is the realm of infinite sets, collections of numbers that stretch on forever. Consider the natural numbers, 1, 2, 3, and so on. They go on forever, right? Now imagine all the even numbers, 2, 4, 6, and so on. This set is also infinite. But is one infinity bigger than the other? This is where things get really interesting. Our journey into the infinite takes us from the vastness of space to the intricacies of numbers. It's a journey that reveals the elegance of mathematics, and its surprising connections to the ancient wisdom of philosophers like Pythagoras. So, buckle up. We're about to explore the universe in a whole new way. To navigate the realm of infinity, mathematicians developed a special set of tools, Aleph numbers. The first Aleph number, Aleph null, 0, represents the infinity of the natural numbers. It's the smallest infinity, but there are bigger ones. Imagine the set of all possible decimals between 0 and 1. This set, called the continuum, is also infinite, but it's a bigger infinity than Aleph null. We represent it with Aleph 1, 1. And guess what? There are even bigger infinities beyond Aleph 1. Omega, on the other hand, represents an ending point, but it can also be used to describe a process that goes on forever. For example, the set of all positive integers has no end. We can say it approaches omega. Aleph numbers and omega are not just abstract concepts, they have real-world applications. In computer science, they help us understand the limits of computation. In cosmology, they help us grapple with the vastness of the universe. When we talk about infinity, we need to distinguish between two types of numbers, cardinal and ordinal. Cardinal numbers tell us how many. Ordinal numbers tell us which one in a sequence. For example, the cardinal number of apples in a basket tells us how many apples there are. The ordinal number tells us the position of a particular apple in a line of apples, first, second, third, and so on. With finite sets, the distinction seems straightforward, but with infinite sets, it gets more complex. The set of natural numbers is infinite, but each number has a specific position, an ordinality. The number 1 is the first, 2 is the second, and so on. This is where the concept of countable infinity comes in. Understanding the difference between cardinal and ordinal numbers is crucial when dealing with infinite sets. It allows us to make sense of their structure and explore their properties in a meaningful way. Pythagoras, the ancient Greek philosopher and mathematician, believed in the interconnectedness of numbers and the universe. He saw numbers as the building blocks of reality, and he found patterns and ratios that seemed to govern everything from music to the movement of the planets. Pythagoras is best known for his theorem about right triangles, but he also made significant contributions to our understanding of music. He discovered that musical intervals could be expressed as simple mathematical ratios. This led him to believe that the universe itself was a kind of harmonious symphony governed by mathematical laws. Pythagoras also believed in reincarnation, the idea that the soul is reborn into a new body after death. He saw this process as another example of the cyclical nature of the universe governed by mathematical principles. He believed that by understanding these principles we could unlock the secrets of the cosmos and our place within it. Pythagoras' ideas may seem mystical to us today, but they highlight the enduring power of mathematics to inspire awe and wonder. His legacy reminds us that the pursuit of knowledge is a journey of discovery, full of surprises and unexpected connections. It encourages us to look for the hidden patterns and harmonies that connect us all, from the smallest atom to the largest galaxy.